Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will write numbers in base 10 as recurring decimals in different bases. So let's start off with a half in base 10. We're going to convert that to base 7. Now a half, of course, is just 0.5. So we're going to start by converting it to a decimal. Now even though this is a terminating decimal in base 10, a half yields a recurring decimal in base 7 because 7 is not divisible by 2. 2 is not a prime factor of 7. So let's look at how we would do this. So we start with our 0.5. Now each time what we're going to do is times by 7 because we're in base 7. So 0.5 times 7 is 3.5. So what we do is we subtract the integer part so that we're left with the decimal 0.5. Now we're going to go through the process again. We're going to times what's left over 0.5 by 7. So we got 3.5. We take away the integer part, we're left with 0.5. So hopefully you can see a pattern. This is just going to keep going forever and ever. It is these numbers here that give us the decimal expansion. So 1 over 2 in base 7 is going to be 0.3 recurring because these 3's are just going to keep going forever and ever. This process will never stop. So basically we can stop when we see the pattern, and that happens when we get back what we started with. So a half in base 10 is just 0.3 recurring in base 7. Let's look at another example. So let's look at 1 over 6 in base 10. This time it's a recurring decimal. So 1 over 6 in base 10 is 0.16 recurring. Once again, we're going to take our decimal and we're going to times it by 7. So if I times it by 7, you can use your calculator for this, I get 1.16 recurring. So what I do is I take away the integer part and I'm left with the decimal part. Now I'm back to where I started, so I could stop there, but just to show you, if I times by 7 again, so that means I'm timesing this, what was left over by 7, I end up with the exact same thing in the next go. So if I were to keep going, I just simply end up with a whole string of 1s. So 0.16 recurring is equal to 0.1 recurring in base 7. All right, let's now look at a harder example. So let's convert 3 over 10 from a base 10 number into base 6. So we convert 3 over 10 to a decimal, so that's 0.3, nice and easy. Now this time we're going to times by 6 at each step because we're in base 6. So 0.3 times 6 gives us 1.8. We take away the integer part, which is 1, and we're left with 0.8. It's what's left over here that I then times by 6 in the next iteration. So 0.8 times 6 gives us 4.8. So I subtract the integer part 4, and I'm left with 0.8. And then if I were to take this and multiply by 6 again, the exact same thing would happen. I'd get 4.8, take away the integer part, and I'm left with 0.8. Now you can probably see the pattern here. We're never actually going to get back to 0.3. These 4's are just going to continue forever. So we have 0.3 in base 10 is equivalent to 0.1 and 4 recurring. It's only the 4 that's recurring in base 6. All right, let's look at one more example. So now we're going to convert 3 over 10, which is 0.3, from base 10 to base 8. So this time we will multiply by 8. So 0.3 times 8 is 2.4. We take away the integer part and we're left with 0.4. Now I times that by 8. So 0.4 times 8 is 3.2. Take away the integer part, I'm left with 0.2. So now I multiply what's left over, the 0.2, by 8. So I get 1.6, take away the integer part, and what's left over, 0.6, I times that by 8 in the next iteration. So 0.6 times 8 is 4.8. Take away the 4, I'm left with 0.8. So now when I do one more iteration and times 0.8 by 8, I get 6.4, which leaves a 6, and the remainder is 0.4. So I'm back to where I was here. So I know that once I hit 0.4, I'm just going to get 3, then 1, then 4, then 6. That is just going to repeat forever and ever. So 0.3 in base 10 is equal to 0. I started with a 2, and then when I hit that 0.4 left over, I get 3, 1, 4, 6. And that pattern's going to keep going and going because I'm never going to be able to get back to 0.3. It's just going to cycle through 0.2, 0.6, 0.8, 0.4 forever. So that part will be recurring, and we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.